Well, yeah, now we have a look at finding the area between two curves, which again is an integration question. So I've gone with the friendly parabola that we had before, and I've now just put on a straight line, y equals x. And we want to find out what this little piece of area under here is. Okay, so a couple of issues here. One is, how do I deal with two curves? And the second one is, what are my limits? I mean, where is that point and where is that point? I'm going to need to know those things. And basically this is it's like simultaneous equations. I know that at that point the two things are equal, and at that point the two things are equal. So at those 2 points, these two things are equal. So both the y's are the same, so I can just match up the x's. So x has to equal x squared. Basically I'm substituting that one into there. So at that point, x has to equal x squared. And that's just a quadratic, so let's write it looking like a quadratic. X squared minus x plus nothing in this case equals nothing. And then we're going to solve it, so it's factorised. So x minus 1 equals 0. So x equals 0 or x equals 1 are the two solutions. Okay, so this point is the point 0, and this point is the point 1. Okay, so I now know my limits of integration, which is cool. So that's often the first step, is you have to actually go through simultaneously, solve for something to work out where your limits of integration are. Once you've got those, the area is just the answer to an integral question. So it's the integral from 0 to 1, so we're just looking at what's between here and here. And the thing I want, this little piece in here, is that one take away that one. So it's just x minus x squared. Top one minus the bottom one. Whatever's on the top of the two graphs, take away whichever's lower graph through that portion. And now it's just a matter of doing it. So we've just got to, like we did before, first step is to, this is area. So the first step is to actually do the integration. So if I integrate x, I get a half x squared. If I integrate x squared, I get a third of x cubed. I haven't dealt with the limits yet, so I better hang on to those. The integral sign and the dx have gone away because I've done the integration. I've finished with those. So now I've got to deal with the limits. So top one goes in first. A half of 1 squared minus a third of 1 cubed. Take away bottom one going in. Half of a 0 squared minus a third of 0 cubed. Okay, so what do we got? That's a half of 1, it's still a half, minus a third of 1, so a half minus a third is a sixth, minus, that's 0, or that's 0, so that's all 0, so 0, so a sixth. So the answer is 1/6, whatever your units are squared. Okay, and again, just ask yourself the question, does that seem sensible? Well, if that's 1, then that's 1 as well, because y equals x, or y equals x squared, and 1 squared is 1, so it works for both equations, which it must do. So this whole square here is 1 square unit, and the bluey bit looks to be about a sixth of that. That looks reasonable. Okay, so if you're trying to find the area between two curves, you first of all got to make sure you know where your limits are, and then you just do it as a subtraction between the two curves, and the integration looks after the work and gives you an answer to that sort of expression. So quite a useful thing to be able to find the area between two curves.